All right. Looks like the attendee number is has sort of leveled off, so we'll get started. I would like off the top to acknowledge the Algonquin Nations, whose traditional and unceded territory most of us here online are gathered upon today. And if I know this brings in people from different parts of Canada and maybe even the world, but just a moment to recognize the Indigenous land in which you may be on. All right. Okay. Welcome, everyone, to our ongoing webinar series here at CNL. We do these bi-monthly, and we pick topics sometimes on suggestions from the audience, or sometimes on things that are important to the projects or what CNL is working on here. Today we have a presentation from Ducks Unlimited on their naturalized water management pond design as part of the near surface disposal facility. So we have a few fellows online who are going to walk us through that today. Before I get started, though, I should probably introduce myself. I'm Mitch McKay. I'm the manager of stakeholder relations for environmental remediation management here at Canadian Nuclear Laboratories. I'm here housed in Chalk River, and we're super excited about this partnership with Ducks Unlimited and this presentation today. I think you'll find it very interesting, and hopefully it will help you learn something about some of the aspects of the design around surface water management. So it's just some of the housekeeping before we get started. This webinar is available in French and English. You can toggle the French and English through the interpretation button there at the bottom of your screen in the Zoom platform. There's also a Q&A button there at the bottom. That's where you can, if you have any questions, you can type in your questions there, and we'll towards the end of the webinar today, we will have a Q&A session where we'll answer questions. I just want to kind of contextualize that session. We are staying within the scope of the presentations today. So obviously we're talking about surface water management and the pond design by Ducks Unlimited. We're not going to be talking today about anything related to the near surface disposal facility design or any of the nuclear type operations. This is strictly on the surface water management and the work that Ducks Unlimited is doing related to that. And I think as we get into the presentation, we'll get a good understanding of what that scope is. You can still ask your questions if there are questions outside the scope that come into your mind, and we'd be happy to answer those through our another mechanism by providing email back. So feel free to ask your question, and we'll be happy to get back to you at a later time. As with all our webinars, they are posted to our YouTube channel. I think as we move through this presentation, we'll see the list of them. So if you have missed some of our webinars, you can go back and look at what we've presented in the past on some of these interesting topics and view those at your leisure. So with that, I think we're ready to get started, so we can go to the next slide. So yeah, Today we are very pleased to be talking about Ducks Unlimited and the water management pond designs. I think the next slide is, yes. So these are the topics that we've covered to date. We've been doing these since 2018. And so there is quite a bit of information on our YouTube channel with all the Q&As. So you can go back and see a wealth of information on the various projects that are happening here at the Chalk River site with respect to environmental remediation management, but also at some of our other sites across Canada. So we've done quite a bit on the Whiteshell project, as well as Douglas Point near Kincardine, Ontario. So with that, I think I'm handing it over to Craig to introduce himself and Ducks Unlimited. Craig, over to you.
Hey, thanks, Mike. So good morning, everybody. I'm Craig Cochran. I'm an environmental engineer at CNL based in Chalk River. I have a background in contaminated site characterization and remediation, and I'm supporting the near surface disposal facility project as a project engineer. So today we're going to go through a presentation. I'm just going to go through a high level overview of surface water management at NSDF before passing it to Ducks Unlimited. So for those of you who aren't terribly familiar with NSDF, it's a fairly simple project in terms of how the facility is laid out. But the main feature is the engineered containment mound, and that's the large oval shape you see at the top of the figure on the slide. It's a series of disposal cells, like a traditional landfill, with various phases. So we fill our cells up 1, 2, 3, 4, progressively filling them as we get remediation and decommissioning demolition type wastes. And as we fill up one cell at a time, we'll put a cover on it. We move on to the next, move on to the next, move on to the next until the entire containment mound is full. It's set up in 2 phases. You see a road bisecting through the middle of the containment mound. Phase 1, kind of on the top of the figure, would be our first phase. That's 6 cells. And then after those are closed, we would move over to the south side, build some cells in that end, and progressively fill it. In addition to the engineering containment mound, we have all of the supporting facilities that go along with the NSDF. The big one would be our wastewater treatment plant. That's for treating contact water, which is any water that either contacts the waste, so rainfall touching the waste, percolates through the waste, your leachate, or even any water that has potential to be contaminated. So stuff that falls on operating areas where there's a potential, wash down water for cleaning vehicles and that sort of thing. We would call that contact water. That all goes to the wastewater treatment plant. The other buildings that you see scattered around the figure would be our administration support buildings, like where our offices are, truck scales, a decontamination facility for vehicles, power distribution, water distribution. So a small little bunch of supporting facilities. Our treated water, which is what this webinar is all about, that treated contact water out of the wastewater treatment plant gets discharged in one of 2 ways. Our primary discharge is to an exfiltration gallery. That's a leaching pit, essentially a septic bed that leaches into ground, just to the right of the wastewater treatment plant, if you're looking at the figure. And that's just a slow seepage from the site of that treated water. And in the case that exfiltration gallery is not available for some reason, high groundwater, maybe in the spring when we get lots of snow, or maybe we have a massive storm event and the infiltration just can't keep up, we have a secondary discharge route where we have a direct discharge via diffuser to Perch Lake. So just to go back to the wastewater treatment plant. So this is contact water, anything that has potential to contact waste. It's collected through a series of pipes and pumped up to our wastewater treatment plant into 3 large tanks. that you see on the figure below here. It's passed through the wastewater treatment plant through a series of different treatment units, chemical precipitation, filtration, ion exchange, and those type of treatments before being discharged to those two routes, the exfiltration gallery or the discharge to Perch Lake once it's treated. And it's treated to a level of our discharge criteria. You can dig through the EIS. There's a lot of them. And those criteria are set based on ecological and human health receptors. So the other type of water management that we have on NSDF is for non-contact water. And non-contact water is any kind of water that has no potential to contact waste. So this is the type of water that comes off of our rooftops, the stuff that comes off of parking lots, off of grassy areas, that sort of thing. And to deal with those type of water effluents, because they're important too, we are using currently in design 3 surface water management ponds. And these 3 surface water management ponds, they'll function as a traditional stormwater pond, same as you'd see in any city or town. As I mentioned, these receive water from roads, parking lots, rooftops, and the intent of having a pond is to control all of that runoff water from rainfalls, both for flows. You want to buffer flows that go out, off of your property. You don't want to have all of that rain that's going at a very fast speed through ditches and culverts and off of asphalt. You want to slow it down, preventing erosion and stuff downstream. And also we want to also control sediment. And in the case you may have some sand and silt that comes off of a parking lot, especially this time of the year when you have all the winter sand and stuff on them. These ponds help collect and trap sediment before the water passes through and ultimately off of the property line of the near surface disposal facility project. And these ponds function for both normal rainfalls, your day-to-day rainfalls, but also for major storm events. And the idea is you want to match your constructed condition or your as-built condition. You want to match the hydrology of the area as best as possible to the pre-existing condition. So I guess just to put all of that in context of where this is in terms of the Chalk River site. So the near surface disposal facility and all of those features I just mentioned are situated in the Perch Lake watershed on the Chalk River property. And the Perch Lake watershed, it's an area that we know and we understand very well. We have 70 years of research and past projects and operating experience to pull from. So the groundwater flow in this area has been well studied, decades and decades. It's kind of we advocate ourselves as being the forefront of nuclear science and technology for Canada, but we also do a lot of environmental research that mostly around Perch Lake. A quick Google search and you can find thousands of, maybe not thousands, but hundreds and hundreds of journal articles on the Perch Lake watershed. So not only do we have all of that information to pull from, we also have all of our NSDF specific data that we've collected for the EIS, for the geotech information. Even right now, we have continuous water level monitoring at about 20 locations in and around the NSDF footprint. On the surface water side, this watershed's been studied, like I said, for many decades. Perch Lake, actually, all of the inflows, all of the outflows have all been measured. They all have monitoring stations. Some of those were actually, several decades ago, those were Environment Canada stations that you can still pull up data from to this day if you go on their website. So we know the water budget inside of Perch Lake really well too. We know how the creeks flow in, we know how the creeks flow out, we know the seasonal up and downs. It's a well-studied lake. And just to kind of top it off, we have even a weather station out there, so we can do temperature, wind speed, evaporation. So kind of anywhere a raindrop falls, kind of within the area on that figure shown on the on this slide here, we have a fairly good understanding of where that raindrop's going to go, where it's going to travel to, and how long it's going to take to get from point A to point B. And what this means for NSDF, we have a large network of groundwater monitoring wells that we can monitor before, which we're doing right now, during operations and post-closure of NSDF. And we have multiple checkpoints where we can check this upstream, immediately downstream, and at several points along the creek, all through the Perch Lake watershed. So that's sort of how all of our discharges, our stormwater, our wastewater treatment plant fit into the overall Chalk River setting. And there's lots of information on that if you dig through the EIS and lots of figures. So where this comes to, I guess, is the NSDF Effluent Strategy Focus Group, which happened back in 2019. So in 2019, CNL hosted a workshop for effluent discharges, and this was in response to concerns from the public and regulator comments on the first round of the EIS in 2017. At that workshop, CNL brought up a bunch of options of the proposed effluents, both treated and non-contact, to solicit and seek various stakeholder insights and input on what we were doing, what we could do better, and if there were alternatives that we should be looking at. And the discussions and the feedback from that workshop were kind of meant to feed back in to improve the design, to improve the EIS, to improve all of the various licensing and environmental documents that we had to go to keep the project moving forward. The options that were discussed are pretty high level. I mean, we could discharge it to ground, which was the exfiltration gallery, which was in the original design. A discharge to surface water, which would be something like Perch Lake, a hybrid of the two, a discharge to ground and a discharge to surface water, which is ultimately what's in the design right now. And at these type of focus workshops, right, nothing is off the table. You want to look at everything and anything and get the best possible solution. So even things like a no liquid discharge, evaporation, and stuff into air, like those type of options were brought up in that meeting. One of those options that we took and started to run with, that was suggested by stakeholders, was a discharge to ground and surface water, which was kind of the thought that everybody was going with, but to use artificial wetland enhancements in our discharge. And I guess on this slide here, that's exactly what we pursued. So one of the stakeholders that suggested we look at different types of things, constructed or artificial wetlands, naturalizing systems, and they even mentioned using companies such as Ducks Unlimited. So CNL reached out and retained Ducks Unlimited to investigate the possibilities that we could of taking what was in our current design, and is there any ways that we could add some artificial wetland components into it, naturalize these systems? Is there any way we can make these better? We started off engaging with Ducks Unlimited on feasibility, and obviously CNL, we had to bring our designer into the fold with AECOM. So we had our engineering team that did the original NSDF design, Ducks Unlimited, CNL, to look into this option. And with that, I'll pass it over to Ducks Unlimited to carry on the presentation.
Great. Thanks, Craig. Can everyone hear me okay? Yep, good. All right. Well, good morning, everyone. And thank you for inviting us to the webinar this morning to talk about the naturalized stormwater ponds and the polishing pond design. My name is Mike Williams, and I manage our environmental consulting service here in Ducks Unlimited in Ontario, and I'm joined by my colleague Graham Jansen, who is the professional engineer that worked on the designs of the wetland systems that we're going to talk about today. But before we begin, I'd like to mention that the Ducks Unlimited office that I work out of is located in Barrie, Ontario, which is the traditional territory of the Anishinaabe people, which include the Ottawa, Ojibwe, Potawatomi nations, collectively known as the Three Fires Confederacy. We also acknowledge the Wendat Nation, who occupied these lands prior to the middle of the 17th century. And here at Ducks Unlimited, we are dedicated to honoring Indigenous history and culture and recognizing the enduring presence of Indigenous peoples on this land. We are committed to moving forward in the spirit of reconciliation and respect with all First Nations, Métis, and Inuit people. So Graham and I are involved with the environmental consulting side of Ducks Unlimited, and we work with industry and developers that require our habitat restoration services for a variety of reasons, either regulatory or voluntary in nature. And I should point out that Ducks Unlimited is not a regulatory agency. We're strictly a service provider for clients looking for cost-effective, sustainable, nature-based solutions. Next slide, please. All right, so a little bit of background for those of you that may not know much about Ducks Unlimited Canada, our company and what we do. Ducks Unlimited is the most highly recognized conservation organization in Canada. Sound science drives our programs, and we're a private not-for-profit organization whose mission is focused on wetlands and associated habitats, as their conservation benefits waterfowl, obviously lots of other wildlife, and contributes to healthier communities. Wetlands, as you may know, are the most diverse ecosystems on the planet, but they also provide many other ecological goods and services, as you see on the diagram on the right, including groundwater recharge, surface water filtration, flood mitigation, and carbon sequestration, which all contribute to healthier climate-resilient landscapes. Our company has been around since 1938. In fact, this is our 85th anniversary this year, but we've been operating in Ontario since about the mid-70s. So we have a lot of experience in designing and delivering various types of wetland projects. We can't achieve our mission alone, so we work in partnerships with many other conservation and government agencies, as well as private landowners. In fact, we have over 21,000 members in Ontario, along with 1,200 dedicated volunteers. And to date, we have over 1,500 conservation projects across Ontario, involving about 2,000 private landowners. And recently, we surpassed the 1 millionth acre conserved, so that was a huge milestone for us. We also have a big marketing communications team that gives us the ability to share stories and our research through various communication platforms, including our National Conservator magazine, our electronic eDuck newsletter, and the Ductario newsletter that gets circulated to all of our volunteers in Ontario. Next slide, please. Since about 2012 in Ontario, we've been offering our habitat restoration and treatment wetland design services to clients on a fee-for-service basis. This helps us generate revenue that goes back into wetland conservation work on the ground. We have a national team of biologists and engineers that are experienced in designing cost-effective and sustainable nature-based solutions for our clients that enhance biodiversity and improve overall resilience to the impacts of climate change. To date, we've designed and constructed over 100 naturalized surface water management ponds and treatment wetland systems focused on improving water quality and lowering long-term maintenance costs. And I should point out that acronym SWM, when you see that in the slide deck, that just stands for Surface Water Management. Next slide, please. So engineered wetlands can help improve biodiversity, water quality, attenuate flooding, improve groundwater recharge, store carbon, and overall contribute to landscapes that are more resilient against the impacts of climate change. They're often utilized as part of a water treatment chain that can involve traditional engineered solutions like treatment plants, oil and grit separators, and low impact development features. There are many different kinds of treatment wetland systems. Some are designed for treating stormwater, some to treat agricultural runoff, and some to treat wastewater. And when you get into wetlands that are specifically designed to improve water quality, they aren't necessarily that attracted to wildlife, as they don't provide a rich, interspersed aquatic plant community that provides cover and food. At the NSDF site, the CNL team was interested in nature-based solutions to improve water quality and lower future maintenance requirements, rather than to attract wildlife. Next slide, please. All right, so let's talk about our scope of services at the NSDF site. We are asked to prepare designs and drawings for a polishing wetland and 3 naturalized surface water management ponds. Again, these wetlands are not being designed to attract wildlife, treat, or remove radioactive isotopes. The diagram at the bottom right illustrates DUC's unlimited scope of services and the location of the design wetlands in relation to the flow of treated water from the wastewater treatment plant and the non-contact water moving through the surface water management ponds. I'll get into the details of the design in a minute here, but the polishing wetland will be located between the wastewater treatment plant and the exfiltration gallery, as you see in the diagram there. And the 3 surface water management ponds to be naturalized were already in design and located by AECOM. Originally, we considered connecting the surface water management ponds in sequence and adding another polishing wetland to treat water before it enters the Perch Lake diffuser, but these options were eliminated in the early stages of the design work. The calculations revealed that connecting the surface water management ponds in sequence didn't provide sufficient additional water quality improvement to justify the extra cost. And similarly, the option of adding another polishing wetland ahead of the Perch Lake diffuser was deemed to have low cost benefit, given that the Perch Lake diffuser will only be used occasionally when the groundwater table is too high to use the exfiltration gallery. Next slide, please. All right, the proposed polishing wetland is located between the wastewater treatment plant and the exfiltration gallery. As illustrated in the graphic, the wetland will be designed as a cattail monoculture with the adjacent uplands planted with a mixture of cool and warm season grasses that will require less maintenance than turf grass and enhance the function of the wetland. Once established, the site will look kind of similar to the photo in the upper right, only much smaller. The polishing wetland will be less than half an acre in size and only about 1 foot deep, with cross ditches at either end to disperse the flow of water evenly through the cattail. The image in the bottom right shows a simplified side profile of the polishing wetland, where water is piped in on the left from the wastewater treatment plant, hits the cross ditch and spreads out along the cattail edge and flows through the cattail, where the plants take up any excess nutrients in the water, then through another cross ditch where any suspended material will drop out before flowing to the outlet structure and into a pipe leading to the exfiltration gallery. Because we don't want any sediment or organic material getting into the exfiltration gallery, the outlet structure was designed with an elevated intake pipe off the bottom of the pond to reduce any sediment from entering, and there's also a skimmer plate to remove any floating debris. The reason we're using a monoculture of native cattail, or Typholatifolia, or broadleaf cattail as it's known, is that these plants are the workhorses in a wetland when it comes to improving wetland quality or water quality in wetlands. For those of you not familiar with the cattail plant, it has long, flat leaves with a brown cylindrical flower spike that looks like a hot dog on a stick, like the photo you see on the right. Some people mistakenly call these plants bulrushes, but that's actually another type of wetland plant. Cattails are actually perennial plants that are relatively easy to get established, and once established, they do a pretty good job at absorbing excess nutrients. In fact, these stands of cattail are so efficient at improving water quality that some municipalities use these systems as tertiary treatment at their wastewater facilities. They do their work through bio and phytoremediation, which are microbial processes that occur in a wetland that result in an absorption or breakdown of nutrients and pathogens. In this case, the water coming into the wetland from the wastewater treatment plant, as Craig mentioned, will meet discharge criteria to be released, and this polishing wetland will provide supplemental treatment prior to being directed into the exfiltration gallery. The other benefits of this wetland, besides supplemental water quality improvement, include increased storage capacity, which may lead to less use of the exfiltration gallery, and some carbon uptake in the wetland and upland plants. Next slide, please. So at the NSDF site, it's designed to handle its non-contact surface water runoff with a series of 3 surface treatment ponds, as Craig mentioned, before being released to Perch Lake. With regard to surface water treatment ponds, there are conventional designs like what you see above in the photos, with very little in-basin vegetation and mowed turf grass in the uplands. These sites can have numerous issues, including poor water quality, toxic algae blooms, and they attract grazing Canada geese, which further degrade the water quality with their droppings. Click the mouse, please. An alternative to the conventional surface water management pond design is to naturalize the ponds and adjacent uplands. This is the alternative that the CNL teams chose for the NSDF site. Naturalizing the ponds involves the incorporation of wetland vegetation communities that will absorb excess nutrients, leading to improved water quality, and the tall grasses in the uplands not only filter incoming surface runoff, but also deter Canada geese. Next slide, please. So this leads us to the second part of DUC's Unlimited Scope of Services, which was to provide designs for the naturalization of the 3 surface water treatment ponds on the site, which you can see are pointed out in the rendering on the bottom left. These sites were already designed for construction prior to our involvement, so we're not changing the locations or the footprints. We're only modifying the design depths of the ponds. Again, these sites only receive non-contact water. The water that contacts the engineered containment mound goes directly to the wastewater treatment plant. The naturalized surface water ponds will function in the same manner as a conventional surface water management pond, but will have a wetland plant component similar to the polishing wetland I just spoke about. So they'll improve water quality and reduce future maintenance requirements and costs. We'll have the same footprint as the original designs you see in the rendering, but will be shallower, only about 1 foot deep, and have a cattail monoculture in the basin and a blend of cool and warm season grasses in the uplands. So it'll look very similar to the photos you see on the right. We know these systems work because based on recent DUC's Unlimited research that compares traditional wet surface water management ponds. Oh, sorry. Yeah, thank you. Our recent research shows, or that compares traditional surface water management ponds to naturalized systems. Our research shows that naturalized systems emit less greenhouse gas, have lower phosphorus levels, and have healthier aquatic ecosystems than traditional surface water management ponds. The benefits of these naturalized systems include improved water quality, fewer Canada geese because they don't like walking through that tall grass where predators can hide, and because the vegetation we're planting is more tolerant to droughts due to their deep root systems, the site is more resilient to the impacts of climate change. And like the polishing wetland, the ponds are not designed for wildlife habitat. It's not going to hurt if a few red-winged blackbirds or marsh wrens get in and nest in the vegetation, that's fine, but we don't want to have things like beaver or muskrat getting in and chewing up the cattail and potentially burrowing into the sides of the wetlands, which could compromise the integrity of the dikes. So that's it for my presentation. So thanks for your time, and hopefully this gave you a better understanding of DUC's Unlimited's role at the NSDF site. And if you have any questions or want to follow up with me later about our services, please contact me directly. Thank you.
Thanks, Mike. And thanks, Craig, for the introduction as well. I appreciate the information sharing today, and very informative on how surface water is being managed through the pond and the polishing system. So thank you for that. And I think as Mike alluded to, although yeah, if you're interested in DUC services, obviously contact him there at his information on the screen. But right now we have Mike and Craig and Graham available for any questions related to the treated surface water management at the near surface disposal facility. So if you have anything you'd like to follow up with right now, please go down to the bottom of your screen, and there is a Q&A button where you can type in your question, and we'd be happy to answer it here and move the discussion along. Okay. I see we have one in here right now. So first question, what mitigation measures are there if birds nest for protection during construction and operation?
Do you want me to take a stab at that one, Craig, and you can jump in?
Sounds good.
Yeah, I mean, there's going to be a construction phase first when the surface water management ponds are roughed in, and there won't be any vegetation at that time. We won't establish the vegetation until the construction phase is complete, and then we'll start to establish the cattail in the basin. And the only wildlife that we truly want to exclude from the vegetation are Canada geese. Once we establish the or starts the seeding activities and the young cattails start to germinate, we actually put up a goose exclusion fence because we don't want the geese in there, scooping up our fresh seedlings. So we keep the goose fence up for a couple of years until the cattails are high enough that they're no longer palatable to the geese. So those are the only birds that we would keep out, during the vegetation establishment phase. Like I said, there's no, and Craig, maybe you can speak to this. It's more of the fact that it's an industrial site. We don't want to be attracting more wildlife. I mean, there will be birds that come in and probably nest in the cattail, and that's fine. That's not going to be any harm to them, but we just don't want to be attracting large numbers of wildlife to the site because it's industrial.
Yeah, I can just add to that, Mike. It's because we're bound by the Migratory Birds Act and various other mitigations for birds nesting in construction, in operations, and during construction. There's a lot of active mitigation we can do. On trees, we have birds nest in equipments. We have barn swallows nest in sheds and structures. It's an ongoing thing all the time. In operations, it's a lot harder to do, right? Because you can't be everywhere all at once, especially this time of year. But should something nest in a stormwater pond or in a tree on the NSDF site, really our mitigation is we have to work around them. Essentially, right? If we have a nest, we can't disturb nests in the migratory bird season. So that could be, restricting loud noises, restricting stuff happening in that area. If it's in a cedar hedge or something like that on the property, we're not going to trim that hedge. It really kind of depends on the situation that happens, but when birds do come and nest on an industrial site, it really is something you don't want, but you want to try to be proactive and prevent. But it does happen. It happens all over, and we have to react and respond accordingly.
Okay, thanks, Craig and Mike. Got another question in here related to the vegetation species. So are all the plants being used in the wetland native to Ontario? I guess in the proposed wetland. And how were the vegetation communities determined?
Oh, that's an excellent question. So definitely the cattail. So we're only using one species of aquatic plant in the surface water management ponds and the polishing wetland, and that will be Typha latifolia, or broadleaf cattail. The seed will be collected locally, so it will be a local species for sure. The other good thing about cattail is it's very robust and resistant to invasive species. So it'll keep other invasive species like Phragmites and loosestrife out. With regard to the uplands, we actually haven't determined the exact recipe yet because we need to have our native grass specialist actually go in, do some soil samples, and concoct a recipe of cool season and warm season grasses that'll be best adapted to the site. We typically don't use a strict blend of native grasses, but the species we use will be non-invasive. So things like Timothy, orchard grass, for the cool seasons, warm seasons, big blue stem, little blue stem, switchgrass, And the reason we use the blend of cool and warm seasons, again, is to try to avoid invasive species from coming into the site. And our experience has been that when we try to use a native blend of just warm season grasses, over a few years, the site does get invaded by cool season grasses anyway. So we find that blend of cool and warm season grasses seems to hit that right balance of getting something greened up early in the spring to prevent erosion and prevent weeds from growing. And then in midsummer, when those cool seasons kind of senesce, the warm seasons kind of kick in, and then you get that real nice height diversity. So we haven't concocted the recipe yet, but it will be specialized for the site.
All right, thanks, Mike. Next question is about sediment. So over time, sediment and decomposing organic material will build up in the base of the ponds. How is this buildup managed over time, and what maintenance is required annually for the ponds?
Oh, another great question. So on this site, we're not expecting a lot of sediment to be coming into the wetlands just because it's going to be a lot of vegetation. There'll be a couple of roads, but it's not like a residential situation where you've got road sand and other debris that are being washed into the surface water management pond. So we don't expect a lot of sediment coming in. It's true the ponds are only going to be about a foot deep to support the cattail ecosystem, but at either end of the surface water management ponds and the polishing wetland, we have these deeper cross ditches, not only to function to spread the water out evenly through the cattail, but they will also serve to drop out any sediment, sand, whatever is being carried into there. And again, the water coming from the wastewater treatment plant won't have any sediment in it. There could be some, sediment coming in from the sides, but if it does tend to settle out, it will be in those cross ditches. And those are the areas that could be cleaned out, and it wouldn't affect the cattail community at all.
Thanks, Mike. Next question is, could you elaborate a little bit on the longevity of the storm water management pond for the near surface disposal facility? Do you expect that it will integrate seamlessly, for example, not requiring maintenance as part of the natural environment, even after, say, the near surface disposal facility is closed? In, I think the time frame is 50 years or so. Just a question around the longevity and how it will operate over time.
Yeah, sure. Again, because we don't expect a lot of sediment entering into these systems, we expect them to last the full lifespan of that 50-year phase during the operation of the site. And another great thing about the naturalized systems is that there's not a lot of hard engineered structures to remove, no concrete, that type of stuff. So, basically if you pull the control structure out, when you're done, the site will naturalize quite nicely on its own. The cattail beds would likely just, spread out. So yeah, there wouldn't be a lot of cost, to decommission or naturalize the sites. Was there another part to that question? Or did I hit it all? Yeah, I think I've got it all. Yeah.
Yeah.
So again,
so.
with
Yeah.
with the grass communities in the uplands too, right? It's not turf grass that might eventually, if it's not sprayed for weeds, might get taken over by weeds. These grassland communities are very resilient with their deep root systems, and once they're well established, they're there for a long period of time, and they don't need a lot of maintenance.
I'll just add, Mike, in that post-closure of NSDF, right, we still have ponds. We'll have to decommission a lot of the infrastructure around the site. In that period, all of the stormwater, we still have to monitor the site, right? So CNL is still watching, maintaining, fixing erosion, doing what we have to do for that period. And we'll have to make the decision based on what we're seeing in terms of performance, whether we decommission or we let them naturalize. It's both options are there and both are very viable to do, but that's something that we'd have to determine in that post-closure phase of when and how, I guess, is what I mean to say.
Okay, thanks, Mike and Craig. We've got another question, but I think we've already sort of answered it. It's on the low maintenance of and what maintenance is typical once the ponds and wetlands are established, but I think we've gone over that pretty much. We have another one here, sort of an interesting one. Do you use fake swans to prevent geese from wanting to land? The water that going into the marsh, does it go through the wastewater treatment plant? If so, does it go through a UV system and through the specialized sand? Through a specialized sand, this person is referencing the sand found in Texas, but what if it's sand, what is that sand? So the first question is, I guess, for Mike on do you ever use fake swans? And the second one, maybe Craig, I'm not sure how familiar you are with the wastewater treatment plant, but is there a UV system and a sand filtration system? So first one to Mike on the fake swans.
Yeah, well, no, we don't use fake swans. So when we're establishing the cattail, it's basically a moist soil condition, so there wouldn't be, water for a swan to be sitting there. But we have tried fake eagles and other birds of prey, owls like that, in combination with the goose exclusion fencing with limited success. Geese are pretty intelligent, and once they figure out that it's a plastic eagle, it doesn't do much good. We've tried lots of different types of tactics, but the physical barrier of the fence is the best. Geese in midsummer are flightless, so they can't pop over the fence. They just physically, it's better to provide that physical barrier until the plants are large enough that they're no longer palatable to the grazing geese.
And Craig on the filtration system.
Yeah, so just to go back, we have the two systems described. So the one set of naturalized ponds is non-contact water, so that's stuff off of parking lots, roofs that doesn't go through the wastewater treatment plant. So that's traditional stormwater runoff through ditches. The second part, I guess, the polishing wetland, as we're calling it, goes through the wastewater treatment plant, and inside of that facility, our first stage is chemical precipitation. So certain series of chemicals are added to precipitate out the bulk of our contaminants of concern in that leachate water or contact water. The second stage in there is filtration. So once we've precipitated it out, we don't have a huge settling basin like you'd see in a municipal system. Otherwise, you'd need to have, football fields of area. We have a series of filters to filter that particulate out. The water then passes through, and I'm generalizing the process quite a bit. So, but after it passes through that filtration system, the next system goes through a series of ion exchange type systems. So we have natural zeolite, which is a clay material. It kind of looks like cat litter. It's actually a component of some cat litters. That type of material is mined from a quarry source a lot of times. In northwestern US is a place that we purchase it currently from. But there's all sorts of sources, and there's synthetic versions of that available. After which it goes through an activated carbon. That's what you would have in a Brita filter at home, and after that, other types of resins, of which I'm not overly familiar with, but synthetic resins to treat the water. So the water that goes into that polishing pond is acceptable for discharge as is before it goes into this wetland. So that water, I'm just looking at the question, but that water would be treated before it goes there. So we're calling it polishing, but we're not crediting it for treating those contaminants. It was going to the ground. This is sort of upstream of that.
Awesome. Thanks, Craig, and thanks, Mike. Okay, with that, I know we're tight on time now because we do have another webinar coming up, and I will I'll plug that right now. Coming up next, we do have our Whiteshell site and talking about I think their environmental protection program. We will thank everyone for their questions, and as we always do, we'll commit to all those unanswered questions. We'll get back in writing to everyone. And again, I'd like to thank Mike and his colleague Graham for joining us today from Ducks Unlimited. That was a fantastic presentation, and I think very informative for us. And I'll just also plug that this will be available in both official languages on our YouTube channel. So if those who want to view it at a later time, it's there, and those who didn't get a chance, who would like to view it can as well. So again, thanks everyone, and thank you everybody for your participation today. Really appreciate it. Appreciate the questions, and enjoy the rest of your day. And hopefully you have time to join us coming up with Whiteshell.
Great. Well, thanks for having us. Take care, guys. Thanks, everyone.